Okay, we're going to show you the steps to hypothesis testing, and then I'm going to do the first problem in chapter 7, section 2, number 31. So I'm going to try and be a little brief about this regarding the steps, but so you have a series of steps that you have to follow. The first thing that you have to do is establish your null or your alternative. Now, the symbols for the null and the alternative are H sub O and H sub A. Null being H sub O and the alternative H sub A. Now, there is this pairing that always goes on with your null and your alternative. So, your your equals is always with your not equals. Less than or equal to is always with your greater than, and your greater than or equal to is always with your less than. Notice that the null always contains an equality, and the alternative is its pairing, or I'll explain in a minute when I draw the picture. So you have to put your claim on one of these. You have to find the claim somewhere in your statement, and you attach it to either the null or to the alternative. Now you have to draw your distribution for the not equals. You have a two-tailed test, because the middle is where equality is, and off to the left and off to the right is where not equals is. This is your fail to reject the null region, and this is your reject the null region. Okay, so the middle again is failed to reject, FTR, the null, and then the tails are you're rejecting the null. So out here, on the second one is a right-tailed test. Your rejection region is out on the right tail. And then you have a left-tailed test. And again, rejection region, fail to reject region. And it's always the null that you are putting there. So you either reject the null or you fail to reject the null. Catch that, mark it, make sure you got that piece. All right. Now, there's this line in the sand, and we're going to start off with chapter 7.2. And so chapter 7.2 is dealing with INV norm and using the z-test. So to get that line in the sand, you're going to be given some alpha. Now let me stop for a second. Confidence intervals, the default level is 0.95. Hypothesis testing, which is the sister to confidence intervals, has an alpha of 0.05 as the default level. So if none's given to you, confidence intervals 0.95, hypothesis testing is 0.05. Now, we're going to operate with the 0.05. To get the critical value on the two-tail, you're going to do INV norm, and since it's sharing the 0.05, you use 0.025. For the right-tailed test, INV norm 0.95, and for the left-tailed test, INV norm 0.05. Now I'm going to tell you, on the right-tailed test, you can actually just type in 0.05 and recognize that there's symmetry on the normal curve and make the sign positive. It's not a big deal. I'm not doing anything wrong there. All right, and then you're going to type your data into the z-test, and when you do that, you're going to get the mean, and it's going to say mu sub 0. They're saying the mean from the null hypothesis. And then they're going to ask for the population standard deviation. Then it's going to ask for the sample mean, the sample size, and then there's this last line on your z-test. It's got a not equals, and I don't remember if it's the less than or the greater than. I think it's less than, I think it's greater than. Make this line match the alternative hypothesis, just like you would with your directions of your tests. And then you're going to make three statements at the end. You're either going to reject the null or you're going to fail to reject the null. You have to choose one. And the information from the critical value and the p-value are going to tell you this. So if your test stat is out in the rejection regions, you're going to reject the null. If it's in the middle, you're going to fail to reject the null. There's the second part that comes up. It's a p-value. Now, not on every test do we get the p-value. There's a couple that we won't be able to do that because your calculators don't handle it. But the p-value is the probability of getting the test statistic, or one that's more extreme. It's kind of, and I'm being wishy-washy on this because it's not totally correct the way I'm saying this, but it sometimes helps. It's the probability that the null hypothesis is correct, assuming that number in there is true. I could get in a bit of statistical trouble for the way I worded it, but the idea works. So if your p-value is really small, that's the probability that your null is correct. Yeah, if it's really small, most likely it's not. Okay? And so you compare your p-value to your alpha. If your p-value is smaller than your alpha, you reject the null. If your p-value is larger than your alpha, then you fail to reject the null. You might ask about equality. If it's equals, you reject. But I've never had an instance where, or any of the problems that I've dealt with, have ever had an instance where it matches. So you state the second thing is you state your level of significance, so alpha equals whatever, and in this case it was 0.05. And then the third, at the initial statement, you've attached a claim to either null or the alternative. And if the claim is on the null and you reject the null, then there's no evidence to support the claim because you put a line through it. If you have the claim on the null and you fail to reject the null, then you're getting rid of the alternative. Well, then there's sufficient evidence to support the claim. If the claim is on the alternative and you reject the null, then the claim gets supported, so there's sufficient evidence to support the claim. And if the claim is on the alternative and you fail to reject the null, so you're keeping the null, and you get rid of the alternative, then there's a line through the claim, and there's insufficient evidence to support the claim. So now we're going to do, I'm going to quick do problem 7.2, number 31. And we're on page 375 of the book. So it starts off, and it says, you know what, I don't have time. I've only got a 10-minute limit on each of my videos, so I'm going to have to do this on another video, and I'll post it up as well.